want to get to questions?
Let's go to the questions. Go slowly. Sometimes you skip too much.
No, I don't skip any.
And people get upset and say, "Oh, you skipped my question."
Sometimes they ask the same thing like 7 times or something. It's like,
Okay.
I'll get them.
Okay, let's see.
Okay. Oh, this isn't so much a question, but it's a comment on knowledge.
Okay.
Usually you know things, saying if all things go as expected, there are always random things that happen, but that doesn't make you wrong. It just implies there are things you were not aware of.
Yeah, but again,
for example, the comet hitting Earth before the pen hits the ground.
But that's why we should not use the word knowledge or the word wrong, because wrong is an opinion. Wrong and right just means you qualified it. You suddenly gave it a qualification that was unwarranted, not in science. And what is knowledge? Knowledge means that, again, the way we define it is that you can predict something's going to happen, because that's how you prove your knowledge to the professors or whatever. You want to show something to someone, you run an experiment, you say, I can tell you what's going to happen if I do this experiment. Then you have knowledge, if you can predict it without error.
But you can't, because there's always things you're not aware of.
Right, that you're not aware of. There's many things happening out there, variables that you cannot, factor in because you're not aware of them. Like, I'm saying, okay, look, I'm going to let go of this pencil, right? And I let go of it 10 times and say, look, it always falls to the floor. And suddenly I let go of it and it stands in the air. How did that happen? And it turns out that I tricked you. I fooled you. I had 2 magnets, pulling on the metal, inside it. And I just turned the magnets on, the electromagnets on, it stays in the air. And you didn't know. Okay, so you did not know that it was going to fall to the floor. You did not predict. We cannot know. Not even God can predict anything.
As a side note, these questions and comments might be more meaningful if I do them in the moment. I don't want to sidetrack us too much.
We can bring them up anyways. Okay, go ahead.
I'm saying, for the next time, it might be better to do this real time. Okay. Do you understand that the basis of psychopaths is thinking love is a concept? Have you done the Rice experiment, or do you just ridicule it?
I ridicule it.
What's the Rice experiment?
I have no idea. But love is a concept. What is it, a physical object?
Google it real quick.
Is love a physical object? Are you saying that you can draw a picture of love? That it's got shape? That because that's what a physical object is. And there's only 2 types of words. One is concept, and the other group is objects. And so it's either an object or a concept. If you know of a third category, hey, you should bring it on.
In his latest experiment, Emoto prepared 3 jars of rice. He wrote, I love you on the first one, you idiot on the other one, and ignored the third one. After a month, the first jar of rice went sour, and there was mold on the rice in the second and third jar. So that's a no for you. Okay.
Nonsense.
So you're a psychopath.
Yeah, I'm a psychopath. No doubt about it.
Sidestep my question once again, Gaede. What is there to explain without first an observation?
Yeah, you don't need observation. You make an assumption. Okay? You don't need to observe.
What's the
difference? Einstein did not observe space-time. Hawking did not observe black hole, and that means that they cannot give you a physical interpretation for how what's happening to these stars out there that move around. They're giving you a physical interpretation. I don't agree with them because they say there's a singularity full of mass, but that's their assumption. They're saying, well, we can describe it mathematically, and that's our physical interpretation, that there is something out there. Did they observe? No, they observed the sun running, star going around in circles. They did not observe the black hole. That's an assumption. That's an inference. And the same with light. You see light do something. And are you going to say that there's nothing there? There's no physical object there? So you make an assumption. You say, well, let us assume that there's an electromagnetic wave. Or let's assume that light consists of a series of particles that travel in a rectilinear fashion. Then you make an assumption.
Oh, yeah.
That doesn't mean that you either believe or that you need to observe. You did not observe light, the mediator of light.
But this question goes before that. They're saying, how are you even going to ask a question if you didn't even observe something?
And again, the problem with the word observe is that they treat it as proof first. No, that is important. It's important. Let me go through those steps here so that this fellow understands. First of all, it's used as the word proof. That's what observe means. So that's the first reason you got to remove the word observe. But you say, I need to observe. You can only observe what you can see. Visible. We're talking about the invisible. Did you observe the invisible? Did you observe the intangible? Did you observe the mediator of gravity? So can you say that if I let go of the pencil, okay, I can observe the pencil?
Or observing
Did I observe gravity?
Yeah, but without even observing a phenomenon, how can you ask a question?
Again, that's not science. Science is not the observation part, and we don't use the word observe in the scientific method. We say, let us assume. Because you have to make an assumption for the mediator of gravity. You can't say, I observed gravity.
No, that's not the point. The point
that is the point. Remember, that is
the point. Is I guess is asking the question science, because when someone says, oh, the moon goes around the sun,
Yeah.
goes around the Earth, for
Yeah.
example. Well, that's an observation. How can you even ask the question if you didn't see the moon go around the sun?
Yeah, but the question here, it's very tricky because you did not observe the gravitational mechanism. And so people use the word observe and say, well, I observed. What did you observe? You observed the moon going around the Earth, but what you're trying to explain is gravity. You're trying to explain the mechanism of gravity. You cannot say that you observed gravity. So you don't need the word observation at all. You just make an assumption.
You mean you don't need the word observation to explain something?
Right.
Or you don't even need observations.
Where in the scientific method do you find the word observation? In the rational scientific method. In religion, yes, what mathematical physicists do, they use the word observation because they're going to say that we observed the photon. Did they observe the photon?
I don't think that's the.
That is.
That's not what I'm. That's not what I said. Again, like for example, when we're talking about magnetism,
Yeah.
the shape of magnetism.
Yeah.
We're seeing the shape of magnetism, not magnetism itself. We're seeing the effects of.
But
magnetism.
this is the issue. People get confused between the invisible stuff and the visible part.
Yeah, but just talking about the visible part. Here we see the shape of the iron filings, right? So we're seeing something.
I didn't observe anything. For example,
Okay.
I didn't observe anything. I want to talk about this hypothetical situation of a star on the other side of the universe. Did I observe anything? No, I make an assumption. Let us assume there's a star on the other side of the universe. Let us assume there's a moon, there's an asteroid, there's a comet. I can assume anything. I don't need to observe absolutely anything in science.
You're saying you could do science without any bearing on whatever.
I can make a hypothetical. I can make a hypothetical situation.
As long as it follows logically,
Right.
A from B, then you're doing science.
I'm explaining the mechanism, not what I observed, not the observation, but I'm explaining a mechanism, what caused this thing to happen.
Going back to the blind guy, if someone explains, not explains, but gives you these assumptions, there's a rock going out around another rock. Then the guy doesn't have to see anything, but he's still going off your observation. But you're saying that observation is irrelevant. He could have just come up with this.
Yeah.
He could have invented a rock going around another rock, and the blind guy has to say, well, what could be the explanation?
Let me give you another example. ETs, they came in the past and they built the pyramids. Did we observe that? We observed how the how the Klingons came and built the pyramids? No, you see a pyramid.
But you see a pyramid.
You see a pyramid, but you did not observe the mechanism of how the pyramid was built. So you suddenly crash, you bump your nose against a pyramid. And now you have to explain, did you observe how the pyramid was built? And so you make an assumption. You say, let us assume there are extraterrestrials, the Klingons. They came here 2,000, 3,000, 4,000 years ago and they built the pyramids. So you make an assumption. But you did not see how they built it. You did not see, because an observation means you saw it over time and you saw how it was built. And you say, I observed it. No, you did not observe. You just saw a wall.
Okay, but going off of what you're saying, you could do science with imaginary stuff that has nothing to do with reality.
What if I talk about dragons? What if I talk about God? I mean, did I observe God make humans?
So you can do science with dragons.
All I need to do is understand what the guy's proposing. So the guy says, let us assume that God exists, that there is a God, the magician. The guy's got a magic wand.
Well, you know what a magic wand looks
like?
Okay.
And he took a little bit of clay, he put it together, he blew and spit on it.
That's not what I heard. He didn't do all that.
And suddenly Adam and Eve came into being. Okay? Did anyone observe any of that? No, he's making a hypothetical assumption. He's saying, let us assume that God is there and he made man. We didn't see any of that. We did not observe. We just see humans. And you can say, well, I saw a human. Yeah, I mean, what does that have to do with anything? What does observation of a human? You bumped against a human, you bumped against the wall. You don't know how the wall was built. So no, observation has nothing at all to do with science. Observation is only a fancy way of introducing testimony. That's all it is.
We can see the shape of magnetism. I guess talking about the iron filings.
Yeah.
Isn't that your definition of object, that which has shape?
No, that's not the shape, because shape has to be static. And what you have there is something moving. What did James Maxwell say? He said it's matter in motion. What you have to do is stop the matter in motion, and we'll see if those iron filings, if you could do that, right? If you could stop the threads from spinning, which is my theory, there wouldn't be any magnetism, because you don't have the mechanism to pull on those iron filings. And so the question now is put to you. Please make visible, make observable the thing that came in contact with one iron filing. Then you'll have an object. Then we can follow your presentation. Otherwise, you're just doing it with spirits. You're doing it with black magic.
Isn't invisible, intangible, physical mechanism, double ropes, single thread, backed without observation experiment, invoking spirits, religious beliefs?
Yeah, we do it without observation, and it's got nothing to do with religious belief, because it's not a belief. It's an assumption. It's known as an assumption. You say, let us assume.
We're guessing.
Yeah, it's a guess. It's a proposal. You're saying, let us assume that the invisible stuff out there in the universe is mediated by a thread or by a rope or by whatever. That's an assumption. Just like quantum mechanics makes an assumption that, or classical mechanics makes an assumption that there are particles. And they say, let us assume there are particles out there, discrete particles. And that's how they base their explanations. And I'm doing the same thing. I'm saying, let us assume there's a thread, there's a rope. It's got nothing to do with belief. It's a proposal, it's an assumption. You know what assumption is?
What's the difference between hypothetical and theoretical? Is the EM rope theoretical or hypothetical?
Hypothesis in rational science, not in a religion of mathematical physics, not in a religion of what they call science today. In rational science, in true science, genuine science, hypothesis only includes the objects, the definitions, and the initial scene. Theory is the explanation of a mechanism. One has nothing, hypothesis has nothing at all to do with theory.
Is the EM rope theoretical or hypothetical?
The electromagnetic rope is a hypothesis, not a theory.
There
is no theory called rope. This is a rope, okay? This is a rope, and this is an object. And so we're not talking about a theory yet. We're just saying we're presenting the mediator for light and for gravity, which is this invisible, intangible thing that has shape, right? That's what a thing is. And with that, we're going to explain the mechanism.
I think the problem is in ordinary speech, they're used interchangeably. Theoretically, hypothetically.
Yeah.
Do you understand your big joke to the engineering/scientific/physics community?
Yeah, it's mutual. Half of the world laughs at the other half.
What is there to explain without first an observation? Yeah, I guess we went into that.
Yeah.
If humans and other creatures lose their genetic diversity eventually, how living things started with a lot of it? That's
I explained that with a graph the other day. If you look at my previous video, I covered that issue. You have that when, let me explain in a few words. I don't have the graph here to show you, but if you look at a new species, it branches off usually from some other animal, normally, okay? So it gets isolated in a different region of the planet. One example is the Neanderthals. What happens? They migrated, as far as I'm concerned, their forefathers, really, you go back all the way to man of Heidelberg, and even before that, Homo erectus. There was some kind of creature, two-legged creature, 800,000 years ago in England, okay? And if you go there, you'll find these evidences, these pieces of evidence. They found a footprint, they found some elephant bones. They say, who hunted these? Who burned these? Well, they say it's some kind of human that was there at least 800,000 years ago. And that had to be the range of Homo erectus, Homo heidelbergensis, who were the forefathers of Neanderthal. Okay, so Neanderthal came out of these folks. How did he come into being? Well, at some point, Neanderthal branched out. The main line, Heidelberg, died, and what you have now is man of Neanderthal. Now, when he comes out, he goes into a region which is totally different than what his forefathers had. And what happens now? This Neanderthal gets used to the cold. He had no clothes. And so he develops certain genes, or some of the genes pop up that have to live in the new environment, which is different than what man, who came out of Africa, assuming that's what happened, right? Who comes out of Africa in a milder climate, he doesn't have to fight against that, so other genes develop in his world. So these guys are different. Why? Because they had to cope with different environments. And what happens? You take that thousands of years into the future.
But they're both losing genetic diversity?
No. At first, they gain genetic diversity because we have this selection going on because of the climate, the animals they hunt maybe or are hunted by, they have to live in different environments. Because of that, they develop different, maybe one's closer to the sun in the sense that, not like if you're in a higher latitude, what do you have? You have maybe less ozone or whatever. There are different climatic conditions. My point here is the following. When a species gets isolated in an environment, all it can do at the beginning from the mother branch is gain genetic diversity.
So it goes up.
Yeah, it goes up because you're fighting against a new environment. And then once you settle down more or less, then it only can come down. And after that, you can't gain genetic diversity. You can only lose it until you have almost no genetic diversity left, which is the state of humanity today. We are all clones of each other from a genetic point of view.
So it's not
There's not that much difference.
So it's not that a species start off with a lot and it just kept going down. It's like these
Yeah, it goes first. Genetic diversity increases, then it starts getting
once
lower.
It gets used to the environment.
And especially diseases. Diseases are the sifter of genes, because once you conquer a disease, that disease can no longer affect your species. And we are the products of thousands of years, first of founder's effect, followed by population bottlenecks. And that constant process is what made us today. That's why we're all the same. That's why Japanese is equal to you genetically, not because they married in with us, but because their grandfathers passed through the same diseases.
I guess a good example is like 10% of you survive a certain disease,
Yeah.
extreme case. Everyone after that comes from those 10%.
Right, and so we don't have to marry a Japanese or a white man like me, an African, in order to enrich our genetic pool, because their grandfathers and the grandfathers of the Orientals and so on, they all went through the same diseases. That's the sifter.
We're all the same.
We're all the same because of that. We passed all through the same diseases, except for COVID.
Oh, we're going through that one now. But that one's also global.
Yeah.
Also, would atoms look different on the edge of the universe than closer to the center, where there would be more EM ropes arriving to them from more directions?
Yeah, that's a big question that we've dealt with a lot. We've dealt with that in the past.
But we didn't have to observe the center of the universe.
We didn't observe it. Okay, no observation. We didn't observe the end of the edge of the universe, but we can still try to explain what happens.
Would they look
there.
different?
Well, I think they would. We're still haven't finished debating that one completely. We're still trying to crack that egg.
I say they look like teardrops on the edge of the, like a hydrogen atom would look more like a teardrop at the edge of the universe, because all the ropes that makes it would be coming from one direction.
This is my explanation, okay? And again, it's not final. I just want you to get an idea of where I'm coming from with that. The atoms at the edge, completely at the edge of the universe. We're thinking about maybe there's a galaxy, the last star, the last planet, so to speak. Think of it in those terms, okay? And what happens is, what would you see at the edge of the Earth today? Well, you see the edge of the universe, because what happens at the edge of the Earth is you have a magnetic field. So the edge of the universe is not filled with atoms. The edge of the universe is swept by magnetic fields, which are threads. A magnetic field is just a bunch of threads that are twirling around. That's what a magnetic field is. That's what those lines of force are. They're just threads, physical threads. Otherwise, you got to explain the lines of force. What are those lines of force? And they say, well, those are, you put them in there ad hoc to explain
representation.
that.
No, something's pushing. It's more than a representation.
Something is pulling on this, and you're saying that's just a representation. Line of force, we know that because we throw iron filings, they line up, yeah?
Well, what's doing it?
But then what's forcing the iron filing to line up? What comes in contact with one iron filing? That's what you got to identify. If you can't identify that, you're not a scientist.
Next question. No, you're sidestepping again. Einstein saw the Earth and the Sun and explained with general relativity. Newton saw the apple and the Earth and explained. You need to assume about what you can already see.
Well, I talked about that the other day. Newton did not have an explanation. So no, Newton never had an explanation. He said, "Fingo non hypothesis," meaning I have no hypothesis, meaning in rational language, I have no theory. I have no explanation for how Mother Nature does this, especially when he was a particle man. He believed in particles. So he said, I cannot explain it with particles, how the Earth rolls around the sun, how the moon rolls around the Earth. He could not explain it. Einstein did not explain it. He gave us the most irrational thing he could come up with. He says, time is warped. That's what he said. Time is warped. That's the wall that comes up against the skin of the Earth and prevents the Earth from flying away. That's what he explained. Is that an explanation? Is that a rational explanation to say time is warped? At best, it's a description, not an explanation at all. But for sure, it's not an explanation, a rational explanation. That's the physical interpretation Einstein's going to give. So no, there is no explanation from Einstein or Newton that passes rationality.
You do not understand the question at all. You see the moon and the Earth.
Uh-huh.
They go around each other.
Uh-huh.
So in science, you put a rope or whatever invisible to explain. I guess he's saying we only explain things that we notice in real life. So the observation always comes first. The observation comes before the question, I guess is what he's saying.
You cannot explain invisible stuff.
No, but he's saying...
You cannot observe.
I guess he's going even before that. He's saying we couldn't even have questions.
Yeah, we can. We can have questions. I can tell you what's happening at the edge of the universe. I've never been there, but I can imagine it, and I can visualize it, and I can give you an explanation.
But aren't you extrapolating from things you've already seen?
You can go as far as you want. I've seen the pyramid. I have not seen... Observation means over time. Observation doesn't mean that I bumped against the wall. I have to explain how the wall was made. That's what observation means. I have to put every frame in the film.
I guess to the extreme.
That's an observation. You can't say, I observed the pyramid. You had to observe the pyramid to explain it. No. The issue here is you have to observe the construction of the pyramid, not observe the pyramid. That's called see, not observation. Observation is over time, many frames of the film. So you cannot say you observed the pyramid.
I guess to the extreme case, if we were all blind and had no senses, would we have any... would we have any questions?
You can imagine.
But you can only imagine because you have senses, I guess is the point.
It doesn't matter, because the issue here is I did not see God make Adam and Eve. I can still imagine it, and I can still talk about it, and I can still propose it. I didn't have to observe God. I didn't have to observe Adam and Eve being made. I can make a hypothetical situation. You're the guy who doesn't understand.
What is science's relevance to the natural world if science may as well be about totally imaginary objects?
It's not imaginary objects. You
like,
got the
like
word
the dragon.
imaginary. You're talking about imaginary. It's not imagine. There's no such thing as imaginary objects. There are objects and there are concepts. So which one is it? Is it an object? Does it have shape? Or does it not have shape, in which case it's a concept? So if I put a dragon has shape, it's an object. It's not an imaginary object. We don't say that's a red object and that's a big object. We don't use adjectives in front of the word object. That's where the problem is. An object is an object is an object. It's that which has shape. An angel is an object. It's not a concept. It's not an abstraction. An angel is known as an object. Why? Because it has wings, it has a little plate on his head, and he's holy. I can draw an angel for you. I can show you a picture of an angel. I can draw a heart. I cannot draw love. That's why love is a concept.
Do all our assumptions that we make come from past experiences?
I don't know about. I have no experience with the edge of the universe. Sorry. I don't know what the edge of the universe looks like. I can only visualize and make an assumption about the edge of the universe. Was I ever there?
No, but based on things you've seen before, I guess.
Well, you can take that as far as you want. Again,
that's what they're doing.
No, but they're wrong. They're wrong. We make an assumption. Assumption is not an observation. Observation is testimony. We don't use testimony in science. Don't confuse the word observation with assumption. Assumption is something different than observation.
Some people argue that humans can't really eat plants. Plants were eaten as slave foods.
What? Well, I don't know. Okay. I'll pass on that one. Some humans can't eat plants.
So now observation becomes important in irrational science? I don't know if that's a question.
Yeah, we don't use the word observation. Observation is religious people who want to introduce testimony. That's the way we see it. The word observation means proof. The guy is not talking about observation. He says we've proven. We've seen, we've observed the photon. That's what they're saying.
Taken to the extreme, you could say that robots, like a program, can do logic, even though it has no senses.
It has no senses. What do you mean?
When a program does logic, I'm saying logic can be devoid of senses. That's essentially what you're saying.
Yeah.
But again, a good way to show that is programs don't have any senses. It just takes in whatever we give it, and it does logic with it.
Yeah, and again,
and that's what you're saying.
Yeah, but
with rational science, you don't need. You're saying it's a coincidence, basically, that the assumptions that we make are based off of the things we've seen. Like, for example, when we see a pyramid, not how it was built, forget that, just the pyramid, and we want to explain how it was built.
Then you use the word see. But
yeah. But you're saying it doesn't matter if we saw it or not. You could have assumed it.
Yeah, you can assume, you can make an assumption about a pyramid for you. Let's say you never saw a pyramid in your life. You never even imagined it. And suddenly you visualize something and say, what if there were a pyramid made of rocks?
Big. How could it have been made?
Yeah, you can come up with anything. I mean, you don't have to see it. You don't have to observe anything. You can just make an assumption. You can make an assumption, like I said, about God and about Adam and Eve. You never observed God, and it's a theory. You don't believe in that theory, fine. Other people believe in it. So again, it goes to what each person wants to believe. You might say, well, that's not science. Well, neither is space-time. What is scientific about space-time? What is scientific about a black hole? What is scientific about Big Bang? Those are all religions.
There's many non-observed phenomena that we talk about.
Yeah, what is a particle? A particle is a number. That's what a particle. There is no such thing as a particle in quantum mechanics, not a corpuscle. So what is that? Did you observe the particle? It's a collapse of the wave function. That's what a particle is.